Hey everyone, welcome back to Locally Hosted.
We cover AI, ML, dev tools, and infrastructure.
Okay, so Google just dropped a white paper saying your model might only matter 10% of the time.
Yeah, and the other 90% is what I call harness engineering.
Wait, hold on. The model is just the engine?
Exactly. Think of it like a car. The model is the motor.
But the harness is the whole car, right?
Right. The road, the rules, and the traffic laws.
That sounds huge. Did they prove this with numbers?
They did. One team jumped from outside top 30 to top 5.
On what benchmark? Did they change the model?
Nope. Terminal Bench 2.0. Same model, different harness.
So you can fix agent failures just by tweaking config?
Usually it's a missing tool or a loose rule. It's debuggable.
That's actually really encouraging for us builders.
It is. Because we can fix config today, not wait for models.
Okay, but what about the cost side of things?
That's where context engineering comes in. It decides your bill.
Static versus dynamic context? I hear that a lot.
Static is loaded every turn, reliable, but expensive.
So system prompts and global memory are static?
Yes. Agents.md, core guardrails. You pay for every call.
And dynamic context is only loaded when needed?
Exactly. Skills fire on demand. Documents pulled via RAG.
So you save tokens by not loading everything up front?
Correct. It's about progressive disclosure of information.
How do you manage the boundary between them?
Treat it like code. Review and PRs. Version control it.
Okay, so we have a fast engine and efficient fuel.
Now, how do we know it's actually working correctly?
Is that where verification comes into play?
Yes. It separates vibe coding from real engineering.
I feel like vibe coding is just guessing sometimes.
It can be. You need tests for deterministic parts.
Input goes in, specific output comes out?
Right. But evals cover the non-deterministic stuff.
So checking if the answer is right? And how it got there?
Output evaluation and trajectory evaluation. You need both.
A wrong answer with a good path is still bad?
Actually, a right answer with a broken path is worse.
Because it might hallucinate next time without checks?
Exactly. Set the bar at the eval, not the demo.
That's a crucial distinction for reliability.
A demo shows it works once. An eval shows it works always.
So the lifecycle changes because of compression?
AI compresses the lifecycle, but unevenly across phases.
Which phase gets compressed the most?
Implementation. The rest lag behind slightly.
That makes sense. Writing code is faster now.
But verification and design remain the heavy lifting.
So we shift from writing to judging output?
Yes. The job moves from code generation to evaluation.
That's a massive shift in our daily workflows.
It is. Harness engineering becomes the core skill.
And context engineering controls our costs?
Precisely. Balance static and dynamic carefully.
So, what's the big takeaway from this white paper?
Stop obsessing over models. Optimize the harness.
And verify everything with rigorous evals, not demos.
That's the engineering part of vibe coding.
Subscribe to Locally Hosted for more deep dives.
Original source is linked in the description.
Thanks for watching. See you next time on Locally Hosted.